Okay, we're going to focus on polynomials today and characteristics of polynomials, okay? So some of this as we go is going to be a review, things that you already know, like frankly writing polynomials in standard form where it has to go like from largest to smallest with the exponents. You guys have been doing that for a while, okay? So this first part right here, all this crazy stuff up here, we're going to summarize all of that, okay? But that is really saying what I just said is that our exponents need to go from largest to smallest, okay? But you don't need to write this down, okay? Don't worry about that. Okay, here's what it boils down to. Okay, a polynomial function cannot have negative exponents or fractional exponents. If for it to be a polynomial function, it cannot have negative or fractional exponents. So we have 4 examples of functions down there. Some of them are not polynomial functions. We're going to start in the top right corner. Okay, in the top right corner, we see this -1, right? Well, that's a negative exponent, right? So is that a polynomial function? No, it is not. Okay, then we're going to go to the bottom right corner. We have x in the denominator. We have our variable in the denominator. Well, we know that the function of the negative exponent reciprocates it, right? So what that x in the denominator really is instead of it being like this, it would look like this, plus x to the negative first. Because if we were to rewrite it, we would put that in the bottom, right? Or actually, it would be times. Never mind. Okay. Either way, no, it has a negative exponent. Okay. The radical, if you'll remember the radical, if we can rewrite that, instead of it being the square root of, we can put that to the power of 1/2. If it's to the power of 1/2, that's a fractional exponent, right? So it is not a polynomial function. So the only one on the screen that is a polynomial function is the top left. And that's because each one of those has a positive whole exponent, and it can be written in standard form. So it would end up being, if I write this in standard form, I'm going to zoom in, it would be -11 fourths x to the 4th plus the 2/4 would be 1/2 x cubed plus 1/4. All right, that's in standard form. All positive whole exponents. We don't have any radicals. We don't have any exponents in the denominator. So this one is a polynomial function. Okay, moving on from there. Standard form, when the terms are written with the exponents in descending order. So the biggest first, all the way to the smallest. Okay, so what we're going to do is we're going to write this in standard form. What would my first term be here? Which one, Carson? -2x to the 4th, because it's raised to the 4th power. We're done with that one. What's going to be next, Braden? 5x cubed. Okay, Mason, what's next? Plus 6x squared. And then we have minus x, and then plus 8. Our constant is always going to go at the end. And that constant is still going to be our y-intercept, just like we talked about yesterday. Okay. I'm going to give you a couple minutes here. You want to go back? I want you to just copy this chart in. It doesn't have to look exactly like this, but copy your chart in. Pay attention to when the degree is even and odd, and when we have a positive or negative leading coefficient. The thing that we're focusing on here is end behavior. So underneath each of these, we're going to have the left end and the right end. All right, so with even, the most basic one we can think about is x squared, okay, which is our quadratic function, which is going to give us a parabola. So I'm just going to sketch this a little bit. X squared, I know it's going to go like this, okay? What's my left end going to do? Rise or fall? Left end is rise because it's going up. Okay, the right end is also going to be rise. It's our normal parabola that opens up. If our degree is even, both ends are doing the same thing. On the second column, all we're doing is putting that negative in front of it. So again, this is just an example with the most basic of even degrees. But now all that would happen is my parabola would switch, right? So on my left, now my left end is fall and my right end is fall. Odd is a little bit different. The most basic one we have for that is x cubed, which is going to give us our little snake, like that. The left end is fall. The right end, though, is rise. We know that with odd functions, if it's an odd degree, that the left end is going to do the opposite of the right end, and vice versa. So if we put the negative in there, now my snake's just going the other way. The left end is now rise. The right end is fall. When we go back to the even, that could be x to the fourth. Obviously, the picture would look different, right? But you're still going to have the same end behavior. There's just going to be an extra turn in there. Okay, so if it was x to the fourth, there's going to be 3 turns in the graph. Right? So it would be fall and then rise and then fall and then rise. Okay. Same thing for odd. It could be x to the fifth or the seventh. The end behavior is going to be the same. The shape will be different. So I just want to remind you that the examples I put up here were just for the most basic versions of these. Okay. It's not always going to be x squared or x cubed. All right. Next important thing is that note right there. The maximum number of turns for a graph is going to be the degree minus 1. And then for our 2 examples, we're going to identify 2 things. All right, on the first one here, what's our degree? The degree is the highest exponent we have. That's 3. So then how many terms do we have? 2 terms, because it's degree minus 1. On the second one, it's raised to the 4th power, so our degree is 4. Our terms would be 3 terms. Okay. This we've already talked about, but the number of solution matches the degree. Okay, so we have somewhere where it's x cubed. How many solutions are we going to have? 3 solutions. Okay, if we have x to the 7, some crazy one, how many solutions are we going to have? 7 solutions. Okay, so our number of solutions always matches our degree. And then this down here are just some synonyms. Solutions might also be called the zeros of a function. They might be called the roots or the x-intercepts. But your solutions are always going to be on that x-axis when y equals 0. Okay, this is the next thing we're going to set up. And we're going to do this first one together. And then we're going to do something different with the second one. So I want you to write that. And then I don't really care how you organize what's below it. But you're going to have 1, 2, 3, 4, 5, 6, 7, 8 characteristics that we're going to pull out of this polynomial, okay? So go ahead and get that set up in your notebook for me. What is my first term going to be, Peyton, if I write this in standard form? 7x cubed stays as my first term, okay? What's my next one going to be? Eureka? So we have one that's raised to the second right here. Yep, so plus 6x squared would be next. So we have to rearrange it a little bit. Then we would have that negative 5x, then minus 1. So now we've written it in standard form. So once we've done that, make sure you've copied that down. We don't really care about this one anymore. Okay, we're going to look at our new standard form polynomial. Now, what is our degree? Degree is the highest exponent we have. Olivia, what's the degree? 3. How many solutions are there, Malaya? Yes, 3 solutions. How many turns are there going to be, Lex? 2 turns, because our turns are minus 1. All right, my y-intercept, this sounds hard, but it's not. What's my y-intercept? It's that constant that's at the end of the polynomial. It's going to be negative 1. My leading coefficient. What's my leading coefficient here, Jackson? Positive 7. It's important to know whether it's positive or negative. So then now we can use our degree and our leading coefficient to figure out our end behavior. So if it's a odd degree and we have a positive leading coefficient, my left end is going to be fall. My right end is going to be rise. Okay, now I want you to move to the next one. Okay, and again, copy this down, set it up the same way. This one we're going to jigsaw is what I call it. So we're going to pass the iPad. Okay, so one person's going to start us, and then we'll move from there, okay? First term is negative 5x to the 5th. Passes it to Kier. Two x to the 4th. Good. On to Cameron. Let's see that quick. Okay, Cam, who are you passing it to? So we've got negative 5x to the 5th plus 2x to the 4th plus 9x. What's our last term? Great. Okay, now we're moving on to degree. Malaya, the degree of our polynomial is 5. Very good. Passing it to Isa. Number of solutions. Jackson? 4 turns because it's 1 less than the figure E. Your y-intercept is your C. Yep. That constant. Good. Okay, Lex. Leading coefficient is a -5. Great job. So that impacts our end behavior. So our left end is okay, so let's pause and look at our left one and our right one, okay? So they're both odd, right? But this orange one, our original one, had a positive coefficient. This one has a negative coefficient, right? So instead of it being fall, it's going to be what? Rise. So we should have rise right here for left end, okay? So you guys can click on the eraser at the top, and you can change that to rise. And then the right end is fall. It's not going to be rise, rise because it's not even. You're only going to have the same end behavior if it's even. Good. Okay, any questions on that process? It's a lot of information that we can pull out of the polynomial.